Hello everybody. Now today's lesson is to give you a little bit more concepts on your linked list. Okay. The first thing for you to start up your VS Code environment, change your directory to C_lessons. For Windows, run the start_env.batch file to create a command for building or make. All right. For Linux users, you will need to go to the C lessons folder by using the CD. Now we'll need to prepare an extra folder for your code. So please copy, find a basic C2 folder, copy it and paste it. Change the name to linked list challenge. And then inside here, open up the hello.c file. We're going to change the content of this file. So please clear the content. Okay, and have a look at the replit.com link on the screen. And then please start from this following code. Okay, I'm going to use this part of the code. So just go to switch over. Okay, and let's type in something here. Struct node. So we are creating a very simple node structure. And then integer data, that's the data attribute, struct node pointer next. And ending this bit. Let's create a node, structure node. Call it node. Okay, equals. Oh, it's a node pointer. And allocate some space for it, so the size of a structured node. Okay, now if you're onto this step, okay, you'll notice that your memory allocation function doesn't exist, so we'll need to do a hash include standard library .h. Okay, and cd to your linked list challenge folder and do a make. Okay, now you notice that this part of the code is not constant. That's saying you're actually trying to run a piece of code that does not belong in the program space. So we need to place this in program space, so it has to be in a function called int main. And then let's put that in the integer main function. Okay, and save it. And I'm trying to make again. All right. And once you do that, you get a the hello object shows up. So the hello.exe was for the Windows. Okay, so hello.exe. No, we don't want to open it here. Okay, now if you try to run the code hello and it does nothing, which is good because we haven't displayed anything yet. Okay, and the next step, because we are trying to create a linked list in memory and we don't want to print it, we just want to hook up the node next with another node. So let's do that. Okay. So let's try to create a second node. Let's call it node 2 by copy and pasting node 2. And then when node 2 is created, we're going to access, we're going to hook up. Okay, so this is the node's next pointer. We're going to hook it up to node 2. Okay. Then we're going to print out. We're going to map out the data first. So node data, and we're going to say it's a value of 0 here, and node 2 data, it's a value of 1. All right. Now we're going to hook it up. So node, oh, it's already hooked up already. So node next is equal to node 2. So when we call, when we access node next, it should become the node 2. And so we're going to print out. Okay. Now to print out the function, we'll need to use the standard IO library .h. Okay. So print, just move down a bit. I'm going to do a printf on the integers, and say result, comma, this will be the node pointer data. Now we want to access, sorry, the node next's data, so node next, so not node data, node next, and then outside of this parentheses we do data. Okay, and close the printf function, do a build, make, and ./hello.exe. Okay, now the result is 1. Ooh, let's put a new line in here, make it more friendly to read. Run again. Okay, so the result is equal to 1. Now, if you create, if you made a mistake by wiring the node next equals to node and do the build again, the result will be, oops, I forgot to save it, Control S, and then run the hello again, it will be 0. Okay, so that's because the node next is still hooked up to the original node, and then that will be equal to node, and node's data is still 0. Okay, so that by doing this, we manually created a linked list in memory. Okay, and we just print it out to make sure it works. Okay, our next segment is on cable-driven system, and we are expecting to build a cable-driven robot. Okay, and I've shown you some videos in class, and for the models, you will need to use the TIGO flange 3 and TIGO G25 motor to create your box. So it will be a session for yourself. Okay, so use Fusion to create a model that looks like this. So you can have a motor at the back, a flange that locks into, now that flange will be metal, and then you need to print out a winder, okay, for the ropes to wind up. All right, then we're going to look at even more different systems in class, the 2 videos here and also the suspended cameras. Okay, we're not going to play in the slides here. All right, our next problem is to use TKinter as our app library to create a simulation of the cable system, be able to move it around, and then to see the numbers change. Okay, so our major problem is how to calculate the cable length. But before that, we need to quickly swap over to TKinter as a crash course. Okay, by this lesson, you should already know the Python variables function, if and else, for loops, and while loops. Okay, and why do we need TKinter? It's a standard library in Python. Okay, so it doesn't require any other installation. So to start your TKinter library is by simply using an import TKinter as TK. Now let's switch over to our code view, and you should open up your teachables folder. If you find a Python lesson folder in there already, you can use it. Okay, and if you don't, you can recreate a folder called Cable Robot Simulator. Okay, and go to challenge 1. If you don't, then use the link as the above on the screen. Let me show you the link. All right. Okay, the link will be in here. Okay, the link for pastebin.com 0KGU3R6G. You can use it as the starting of a challenge. Now we're going to start from scratch, so using nothing in our TKinter code. So let's create an empty file first. Okay, so create an empty file. I'm just going to switch over to the screen and go back to here. Just close this. Okay, start a new Python file. Call it intro.py. And then with this line, I'm going to import TKinter as TK. Okay, so in short, it's TK. And we're going to create a root window, and it's a TK top level window. All right, and we're going to change its title to make it as a cable bot sim. Root dot, let's do the geometry. I think we should call it a function instead. So let's double check that. Okay. Oh, yeah, it's the function. We shouldn't be changing it as a value. So it's a function. And the geometry is 400 by 400. Okay. And we're going to do a root.main loop. So this calls the main loop event loop, right? If you run the code now, you should see there's a CableBot sim window shows up in your screen here. Okay, close the app to exit the main loop. Otherwise, it will be held onto inside the main loop. So let's add in a label and give it a go. So let's call it. I'm just gonna call it LA, just A1. Equals TK dot capital L label, and the label has a parent of root, or the master root, which is the container, and specify the text as hello. Okay, now after the label is created, if you run this code, you won't be able to see the label because it's not positioned yet. So let's position it. A1.pack. There's three methods for positioning. Packing is probably the easiest because it just puts it right on the top of it, okay, without any attributes. So your turn to create a second label. Okay, add your own label. Pause your video here and try add your own label. Screen. This is the answer. All right. So. All right, now what is the main loop function? Okay, it's also the event loop. You can use this link to check out all the possible events that TKinter can handle. It includes all types of interactions like button clicks, mouse clicks, canvas moves, and so on. Okay, and what is the pack method? It actually positions your widget after you call it, so you need to pack it or there's other two type of methods, which is grid or place. Okay, it's best if you want to use pack as their one-dimensional arrangements. If anything that's like a table, you can use the grid. Okay, for absolute positions, you can use place. And what's a widget? Okay, we have four type of widgets. The first one is interactive. You can actually touch it, move it, drag it, type it in. Okay, and then there's informative ones that you can get value from it. I mean, just displays only. Grouping widgets allows you to group different widgets together, as its name suggests. And we have position widgets we have just talked about. Pack, place, and grid. Okay. Now you can pause your pause your screen for a moment and then try to challenge yourself to recreate the following app by using this link. Okay, so to visually understand what's the name of the text area. Okay, and then and also lay out the buttons as in the examples. All right, now this will be your personal challenge. I won't show you any code at the moment. So we'll need to switch back to the cable problem. Okay, and by getting the pastebin.com 0K GU3R6G, let's have a look at that challenge in the screen. Now, if you look at the code from the top, okay, it's got the TKinter imports, and if this one, okay, okay, that's the program. What it looks like when you first run it, it's to simulate the 4 wires in a cable system in 2 dimensions, and you can see the sliders moving left and right. You can drag them, okay, and the sliders here as well. All right. Vertical and horizontal positions. If you drag your canvas, okay, the item in the middle is called the canvas, it changes the position of your endpoint and also the length of the 4 lines. Okay, so most importantly, how are we going to look at the code? Okay, so go through the code, and then you'll find out at line 43. Okay, there's something for you to do. So we need to call. Okay, so the hint for you is to search for a method for canvas that you can create text upon. So that one is also called canvas.create something. Okay, pause the video here. Oops, I'm just going to move the app away. Okay, pause the video here and give yourself a challenge. Okay, write some code that can display the distance value for that line. So there are 4 distance at the moment. Okay, from top left to the bottom right, 4 distances. Each of them has an position X and Y already calculated at the center of those the lines. Now you just need to make sure you call the correct function and make sure that happens in the right place. Okay, so I'm going to do it. So by pausing your video now, I'm going to continue. So continue to create text, and we'll be throwing in the label X and the Y values. Okay, and if you look at the create text function, it's expecting 2 mandatory fields. The first one will be X. Okay, now you don't type this in. This is just telling you what type of value is expecting, and the name of it. Okay, implicit name. Okay, so the first one is X and the second one is Y. So I'm going to put in the label X, label Y. Now you can put in other values like 100, 200 and give it a try. And also the next attribute we can put in is the text value. Okay, scroll down a bit to see that's the text. And you're expecting a named parameter, so it's text equals something. All right, so I'm going to put in the distance here and run the code. Now you'll see when the code runs, you'll have a very smudging effect, okay, on the screen. So what's going on here? This is because when the canvas gets cleared every time at line 15, it searches for the 3 different tags. Okay, now if you notice that the lines actually gets cleared, however the labels doesn't. So we need to actually tag our create text function, okay, just like the lines do. So comma tags equals create distance label, like this. Okay, and save it and run the code again, and you'll see. Okay, now your label has been fixed to the center of the lines, and it updates itself properly. So those are the values calculated. Okay. Next, let's limit the size, the format. So we'll be replacing the distance variable with a formatting string. Okay, and by putting the distance inside, we specify to 2 decimals position of the float. So it's a format string, put a brace in over the distance and specify 0.2f. Okay, so this is colon 0.2f. This tells us it's currently a value at 2 decimal places. So if you run it, you'll see now the numbers are limited to 2 decimal places. Okay. All right. Now your next challenge is to add position label of the end effector. Okay. So you need to do pretty much the same thing. However, we want the x and y value for the end effector.